Yeah, we're about to start. Shall we start? So, shall we? We're live. Shall we start? السلام عليكم ورحمة الله وبركاته والصلاة والسلام على النبي محمد صلى الله عليه وسلم. Ladies and gentlemen, dear respected audience from all over the globe who are watching in now, I welcome you all to Qatar University, the Research Wednesday series. In this series, in which we will be focusing and shedding light on the Qatar University pioneering research projects together from the expertise from Qatar universities, from the industry locally and internationally. My name is Amani Uthman, and I'm honored to be the moderator for the first webinar of Qatar University Research Wednesday webinar. Before I move into the topic of today and my honored and wonderful guest, I would like to highlight some important points. Number one is just to highlight that this webinar is recorded, and after a couple of days, we will be sending you through your emails the recording of the session in the website link of the Research Wednesday series. So we invite you to register and to be connected and stay tuned with all the activities of Qatar University. The second point is regarding the questions and answers. It will be at the end of the webinar, and I encourage you please to send us your questions on the bottom and left-hand side of the window in front of you, so we can take those questions and we give it to our guests. And in the first webinar of Qatar University Research Wednesday series, we will be presenting to you one of the most important projects supervised by Qatar University Office of Research and Graduate Studies in collaboration with a number of partners such as the European Space Agency, NASA, and other leading space sciences partners. Today's topic is Cancer in Space, taking the Qatari flag into the international spaceship. And in here, on the stage, let me introduce our guests. Engineer Abdulrahman Kaldari from Sat, the Qatari satellite company. Welcome, Abdulrahman. And I have also with me Dr. Okay. Well, as you can see, I have a lot of papers with me. So Dr. Serhi Socialensky. Dr. Serhi is a professor on molecular from the College of Medicine at Qatar University. Dr. Serhi, you have 137 publications, 5 patents, and more than 7,000 citations in this area. And you are very much interested in cancer in space. So I welcome you on a stage. And would you please tell us, what is cancer in space? And why cancer in space? The floor is yours.
So thank you very much for the introduction. And I must say that when Ms. Amani mentioned about collaborators, I think major collaborations are coming from universities. It's QU, it's in Doha, it's in Uppsala, it's in Ukraine, and Ice Cube space application services. They were very, very patient. They are very patient with us. But first of all, it's Office of Research Graduate Studies of QU. So if we're talking about why cancer, I have a few slides. And the first one is to say a little bit about goal of this project. And this goal has key aim is very practical. We want to develop some tools which would allow us to handle cancer a little bit better, specifically in area of diagnostic, because there is a lot of work done so far, and there is a lot of success in fighting cancer. However, as long as people are dying from cancer, it means we still do not have solution. We don't have good solution. So this is a, oops. Sorry, jumping. And this is the first and major goal of this project, looking for better treatment of cancer. The second one is a little bit more academic. It's to looking on mechanisms of controlling human life, because we know that we are dependent from things which are happening in the universe. It's not only what is on Earth. And the third one, which is also a little bit practical, a little bit more practical, is hopefully we will be able to contribute to biomedical support programs for space endeavors, of human space endeavors. This is basically about goals.
Wonderful. And Dr. Sirhi, as you're being the principal investigator of this project at Qatar University, this is very pioneering project. It's new in Qatar, and we've never heard of it. Such kind of activities, and also in the region, in the GCC countries. Would you please walk us through the project?
I mean, first, I think that to say it's absolutely new, maybe I wouldn't say it, because I don't know everything what has been happening so far. But in the region, there are very strong activities going on in the Gulf region, and actually there are a lot of activities. What we are trying to do is just one part of those activities, and they are linked to biomedicine. Mm-hmm. And there, when about projects, so what I will do now, I will just go through project, why we do it, what our purpose, what we want to achieve, what are potential applications of this project, and where we want to be at the end. So when we approaches we are using, as I mentioned, it has to do with It has to do with first biomedical part, and this is about studying process of carcinogenesis, what means how normal cells change into cancer cells. Then project itself has this biomedical part. We do it at QU, and I would like to keep it at QU core of these activities. We have to do some engineering, and this is done mostly in Sweden and Ukraine. And there is a space flight, and I already mentioned about IceCube Space Application Services, who are very, very helpful and very patient with us, and taking care of arranging for the space flight. When to talk about problem itself, I use word carcinogenesis, and carcinogenesis defining processes making normal cells into cancer and creating really problems for humans. But from normal, it doesn't go straight from here or there. It goes through different stages. First stage is so-called formation of microtumors, which are local, in small quantities, tumors which are size on a level of micrometers. Then when they grow larger, we may have tumors so-called local. And then real problem starts when these local tumors start to spread all over the body. These black dots, this is actually metastatic tumors. So what we want to do, we want to study what is happening on this stage, just at the beginning, in order to prevent and, if possible, and treat, not if possible, but to treat it. When so far, all oncology or biomedical research was focusing from point of view of physics on analysis of things, analysis of regulatory processes related to electromagnetic waves to strong, weak forces. This is what is defined as a classical chemistry and physics. Practically nobody was looking what is happening with cellular biology when there is a changes of gravitational forces. Gravity force as its gravity as defined as a weight, let's say, or measured as a weight, has been studied in weightlessness and higher G conditions, but not really gravitational force. So idea is that if we go, and in order to study it, one has to leave Earth. And this is where space conditions are coming in. So if we would modify gravity, what will happen with regulatory processes? Will we be able to identify key regulators? Because key regulators means markers and drug targets, what means detection, diagnostic, and treatment. This is what we have in a lab. In our lab, we can see this formation of these microtumors. It's like it's called colonies from cells. We can see these microtumors in blood of patients. So the existence. This is and this is how it looks in a tissue on a section. We can see, so previous slide was on the microscopy pictures, but this slide, it's by naked eye, one can see, you see these tiny white dots. This is microtumors. This is where bad things are starting. Here, you don't have it. Here, you have it. Idea is we want to block development of these microtumors at early stages of carcinogenesis. And when we try to do it, we know how many components we have to deal with. This, for example, is shown cancer regulators in cells of patient with a lymphoma. More than 10,000 components are involved. It's a huge, huge number. And from this number, we have to extract those who are important for tumorigenesis, and because that would allow us to later on to treat this patient. And we can have not only detection, but a real help to patients. For example, here, we could take basically from blood, these microtumors which can be detected in blood. They have a term, circulating tumor cells. We can expand them, make them growing, and then test how sensitive these cells are to different drugs. This is classical, again, it's a classical approach to first identify, expand patients' cancer cells, and then test with different drugs which clinicians think to use. So before even trying those drugs, we can say which drug will work, which will not work. For example, for this patient, testing of two drugs, drug A, drug B, showed that drug A actually may work. Drug B, don't use it because it will not help. And this is practical applicability of our work. Now, if we come to space and to space project, why space? Why we cannot do it on Earth? And so, in order to see that we really may get some interesting and positive and successful results, we have to do some simulations. It's not exactly flying to space, but it's simulation of, for example, directionality of gravitational forces, substrate dependence, many different things. But what is important that here in this part, we can see that, for example, normal cells, this is human keratinocytes, they actually don't survive changes simulating space flight, what means their limit of tolerance is way, way lower. This is the reason why they are normal. While cancer cells, they actually grow. They form different type of structures. You see those structures. This is like microtumors. They survive what normal cells would not survive. And if we would be able to identify what are mechanisms driving those cells and making those cells behave in this way, again, it's a way to markers and drug targets. This is another example. This is mimicking conditions at normal growth. You see this layer of cells, single layer. So those cells, when they get in contact, they don't grow, they don't expand. While if they start to expanding, they form colonies on top of normal layer. And this colony is shown with yellow arrows. And here you see a difference. Normal conditions like on Earth, normal monolayer. Here there is a changes in gravitational force activity. It's usually done on random positioning machine. And we have also cells subjected to higher G forces. They start forming. They lose control. And then we, from this observation on a level of several cells, we have to look into molecular mechanisms. And for us, we're using proteomics core facility at QU. This is 2D gels generated in a lab. You see those spots, this is proteins. And then we compare what is changing in different cells when they're subjected to different gravitational forces. That allows us to build networks, and here is shown regulatory network which controls transition of breast cancer cells from non-aggressive to aggressive. So again, we're getting quite many components involved, but using systems biology, we're actually capable to and can to identify key drivers. So we can see, we can go from 6,000 nodes to roughly less than 100 of most important ones. And then we see, can we use drugs to control those key nodes? And if we can, that means we have a chance to help patients. At the end, what we want to have as a as a practical application in this workflow, it's starting with our devices, going through all procedures I mentioned a little bit in the previous slides, and get at the end something which can be used in a clinic, chip for diagnostic and selection of treatment. How we do it, it's another way of presentation. So this picture from the lab, then with great help from IceCube service providers, I can say even collaborators by now. Idea is that we will take it to International Space Station, but then it has to go back to lab. And then at QU, we want to look, can we translate those results into better tool and get that to clinic, to clinical practice. I mentioned also that would be like addressing the first goal, practical applicability and practical help to patients. Second one, I was mentioning about more fundamental, understanding fundamental rules governing life. And this is very interesting aspect, because today we already learned that C is not actually constant, speed of light. Entanglement is confirmed. And if 11 dimensions, more than 11, are required to describe gravity, it's actually mind-blowing. Why more than 11 dimensions? We used to 3 dimensions and in everyday life. And then if you go outside and you just look on greenery around, you just realize that these green leaves with chlorophyll, they're actually using electron tunneling. That's what makes them so efficient, while human-made devices are very, very far from that. And of course, cancer cells, they don't obey crowd wisdom rules, so call it. We don't know this rule so far, but still, we know that there are such rules. And then there are some observations like here indicating that this broader look with insights from physics, from chemistry, actually may work. Here, for example, are profiles of absorbance different in relation to wavelengths, cells treated with different drugs, with different concentration of drugs, and they are reacting. So there is a reaction, which means there is something there. And another interesting aspect is that despite the different scales, universe, Earth, or subatomic world, the same actually rule applying, and those rules are important for how humans feel, our well-being. To do this type of work has to be teamwork. It's no way, because there are so many different aspects that it has to be people representing biology like me, it has to be people representing clinic, representing engineering efforts, physics, basic sciences, but also even entrepreneurs and pharma developers. They are really important to make science into product, and product which helps people. And because society actually needs that. And not only statistic how many people are dying from cancer, but in just understanding that, listen, we still do not have cure of cancer. We know so much. We know really a lot. But we still don't have cure. So society is hungry for when a scientist will deliver solution. And we're trying to do that. This is actually very, very old. It's from my time in Sweden. What I would like with this webinar, just to show that project which I'm trying to accomplish is only one part. It's a cancer space. It's mostly biomedical oncology with application into clinic. And right now it's supported on QU level. It's also technology advancement, because in order to do this work, we have to have in our lab or close to us different technologies. Different technologies, what means chemistry, physics, engineering, mechanics, not only biology. It has also impact on education. I saw, for example, educational activities of ESA and NASA. It's a brilliant, it's a preparation of people from school to students to look on big problems and solve them. and learn them, listen, you can solve them. Whether we have it in Qatar, we do. I remember a very enthusiastic crowd of people at QU Astronomy Club, AstroCon. So seats are there. Just go to Qatar, go to Planetarium, go to those people, and you would find really enthusiastic people. And of course, national level, because you started with saying about region. So region is working on getting to space and working pretty hard and seriously and very, how to say, on a big scale. And I
with
mentioned
this sort
a little
of
bit
activities,
about
Dr. Serhi, with this sort of kind of what the project is focusing on, the activities going on, is it also aligned with the activities that you are working on this project and the outcomes that you are trying to achieve as part of this project?
Sorry, I'm trying to...
Yeah, I mean the activities that going on the region, is it in line with the activities or the outcomes the project is, the goals of the project?
Actually, it's a different components
Yes.
of the same big problem. And I'm using the word big problem. Because big, not really problem, but big challenge. Because big challenge in this case can be combined like with space. We have here Dr. Abdul Rahman. You represent very different domain. It's not biomedicine,
True.
what you represent.
True.
But it's about the same big challenge for humankind.
True, and we all participate in solving.
So we represent different domains,
Indeed.
but we're both looking up.
Indeed.
Exactly.
Indeed. Yes. Excellent.
And, I have to have one more slide, I'm sorry, because when it's about job, it's not about me only, it's always team. It's always there are people who are engaged in it. It's always team. And here I have to mention, for example, mention people who are currently in the lab working, people who were in the lab very recently, support from Office of Research Graduate Studies, IceCube Space Application Services, and then of course, collaborators on different level, different time scales, and so on from different countries, funding support. Because without this support, without these people, one cannot make it. One person will never make it. And at the end, you see, even in different languages,
Yes.
Thank you.
Well, thank you, Dr. Serhi, in different languages. طيب, this is about the project, which is cancer in space. How is the Qatari flag then is taken to the International Space Station?
Answer is actually very simple, because this project was initiated at QU, it's run at QU, and so far it's done at QU. And therefore, QU, it's Qatar.
Thank you, Dr.
Indeed, thank you. Thank you, Dr. Serhi. Now, Abdurrahman, as being working in the SHAILSAT, which is the Qatari satellite company, would you please tell us, from a national perspective, how is the importance of these kind of technologies and this project to Qatar, to the state?
For sure. And before I answer your questions, I would like to apologize for not having Saif with us, as he had some personal emergency. So due to that, he couldn't come. Back to your question. Space technologies and related applications can certainly support the diversifying the economy and creating a sustainable industry, which is in line with the vision of Qatar 2030. Now, in addition to creating sustainable industry, space technology can help research field and medical field. And in this case, we are trying to treat cancer in space, which can really positively help people's lives. We also notice that a lot of nations have noticed the importance of space and started to allocate resources in their budgets to explore those values. Now, us, SLSAT, being the national satellite operator in Qatar, we are working hard to align with the 2030 vision by developing capabilities in terms of space asset and manpower. Now, we are proud to own fully 2 satellites, SAIL-1 and 2, to be fully controlled and monitored in our Al-Ghawariya teleport, which is the biggest and the most advanced teleport in the region. We also try to sponsor students to keep national students to keep our national's presence in space, either by sponsoring them or by in-job training. Now, if you look at the value chain of space, it's huge and it's broad. So CELSAT took a specific role in that. We are focusing on a specific part of the value chain, which is satellite operations, and that includes telecommunication and broadcasting, and this is what we are focusing on.
Well, so if this is the goal of CELSAT, wonderful. This is a project from a research and development R&D. How does it serve the goals of CELSAT? We are academia, Qatar University,
right.
And that's what we give to the community, to the society, to the
right.
market, to the partners. So how does it help CELSAT from an R&D perspective?
Right. So because, like I said, because it's a broad industry, and
yes.
what we are looking at is a specific part of the value chain. So we have a different mandate, which is not far away from the research, but a different mandate.
Mm-hmm.
So the first one is to actually provide a secure and independent telecommunication and broadcasting services to our Qatari stakeholders in Doha and plus the region. And the second mandate is to be commercially viable and to build a business, a sustainable business. But at the meantime, we highly encourage such inspiring initiatives to help people's life, and starting from Doha.
Thank you so much, Abdurrahman.
You're welcome.
Back to you, Dr. Serhi. So you have already started the journey.
One can say, yeah, we started, but we are still working.
Indeed. So what is your expectation?
Completed. I understand it's a very short answer, but it's true. It's completed with reaching goals we have, and there are a lot of obstacles. It's not an easy. It's not an easy way. Even today, tomorrow has to be taken. Today, tomorrow, and after tomorrow has to be taken a decision, which is very crucial decision. And but if one is scared of obstacles, one will never make a journey. So just to go.
So, Doctor, since you mentioned the word obstacles, and we are now in 2020, and we have the choice whether to describe 2020 as the year of the pandemic or as the year of creativity and unity and productivity. Has the pandemic affected the work in this project?
Actually, very, very much, in both negative and positive ways. Negative ways, it's half joke, but it's actually true. Negative ways because there is no way to travel, and my plan was that during summer to be in Europe to visit partners, because we have partners in different countries, and to look on site what's going on. That would be speeding up work. So that was a negative impact. Positive impact, not being able to travel, then alternative, go to lab. That was alternative.
On the lab and working
But there
on
is also another aspect, of course. And the aspect is that when there are big challenges which are hitting all people, independently race, religion, tradition, and so on, then good people tend to get together.
Indeed.
And this is actually positive.
Yes. And this is, we're witnessing it in different aspects and in different domains, locally and internationally. Doctor, if we're going to ask you about the hub at Qatar University, what would you tell us about the hub?
This is very, very, how to say, this is a question which is close to my heart because from different aspects. I don't know where to start, but I will start from students. When I see students at CMAT, it's a brilliant people. Really, it's a good students. They are very motivated, hardworking, and they really want to achieve it. Of course, I'm talking in general. Always there are variations and outliers, so-called. But majority, yes. Point is, what they will do after? What they will, what options they will have? How many options they give? I saw, for example, College of Business had very good program on entrepreneurship that attracted really good projects. But when I talk to people, I ask them, listen, what you will do next? Oh, we are trying to find a place where we can develop our ideas. They don't have money, but they have ideas. Those ideas can create products. So build the incubators, build them chances. Qatar has QSTP, Cubic, but they have different tasks. What is needed? University, close to people, close to students, close to these freshly graduates with good ideas. Give them a chance for very little money. It should not be for free, but it should be for very little money. Gives them a chance to develop their ideas. And this is the reason why I'm talking about this QU incubator. But it's not on my desk. It's not on my desk. This is a decision of actually Mr. President. That should go to him.
So that's to Dr. Hassan. I think Dr. Hassan is watching us today. Okay, well, thank you so much, Dr. Sarhi. Thank you so much. Back to you, Abdurrahman. How do you see the importance of academic work in this field?
Especially in this field, there are a lot of areas that can be updated and developed. But it has to be through a very professional and dedicated, committed research. Because it'll take long, especially in space, that we don't know what's there. It's not like you can see it. It's not like you can tell exactly what it is. It takes years and years of research to know just one thing. So in 2020, I would say some of those researches that can be done like through academy in Doha is that some of them are such as Earth observation, oil spoiling and stuff, and then you have also Internet of Things, you have machine to machine, and we also work on a lot of opportunities in Doha regarding oil spillings, and we have Earth observation for Ashghal, for other entities in Doha that some of them are public, some of them are private, but we see a huge area that can be developed and updated in Doha. So.
And how do you see the collaboration part of it between academia and between the industry?
Well, it has to be translated from being an academia, and then once the research is done and developed and well organized, then we can translate it into commercial, like Dr. said.
So he was saying,
that it takes time for the research to be mature enough to go into commercializing and into being a product to be sold. So this is what I mean by you have to have a very dedicated, committed research to be able to develop and update certain areas in space.
Certain areas in space. And how do you comment on that, Dr. Sarhi?
I agree 100%. Right now, you mentioned two words. You mentioned academia and you mentioned commercialization.
Yes.
They are a little bit far from each other because academia needs freedom of thinking, freedom of ideas, which are difficult to translate into commercial product. So there is need something in between, something which will filter pure ideas, maybe good ideas, but not really a useful wrong word, not really translated into products yet. There is need something in between, and this is why I'm talking about QU incubator. Because this is where will be ideas developed, matured, and put into products.
Wonderful.
And QU can be stakeholders there. QU can say very simple, guys, if you develop product, 10% of this product will go back to QU over a lifetime of the product.
Wonderful, wonderful.
And,
that's very true.
During my studies in US,
when
I was actually presenting my electrical engineering project, you will see a lot of companies, they will come to you and they will talk to you and they will see if you can be beneficial to their own companies, like to their own goals. So if you're talking about switching academia project to a commercialized product, it needs someone to believe in you.
Of course.
and to invest and not to see the return in short term because it might take long.
Yes. Somebody with vision.
Right. Somebody
Vision,
with vision. Yes.
Yes.
And actually, this way, if I may add, this way is a both way. It's a not unidirectional way, because companies, commercial entities, which do not take science in their portfolio, they don't survive very long time.
Very true.
That's very true. That's very true. Well, I know that there is something, a kind of a talk in Qatar University, a kind of entity that will be helping having those ideas to reach the stage into commercialization. So let's wait until we hear the news about it.
Right.
So thank you so much. You gave us the presentation and you gave us the perspective, Abdurrahman, from as a state for such kind of technology. I would like now to move into our audience and to hear from them if they have any questions or what is their feedback.
Right.
All right. If you can give me just a second. Okay, well, I have a couple of questions, honestly, here. I received them. A question to you, Dr. Serhi. The question says, is this project, well, I think we covered it, but let's repeat it again. Is this project idea is new? And what is unique about this project?
You know, I can give long answer, I can give short answer.
Let's go to short answer.
Short answer is,
Yes.
if this project would not have novelty, it would not be on stage of arrangement of contract, ready for signing for space flight. Because other people were looking on this contract, on this project. So if they would see, no, if they would see no novelty, no originality, no usefulness, it would never reach a stage of a contract.
Okay.
Space contract.
And well, that's very interesting because this is the second question. Our guest is asking. The question is there any current partnership with health in particular, and health hospitals and institutions to apply the outcomes? If there is any agreements?
Whether there is, I would say, agreement or understanding of application, yes, because agreements, it's a legal document.
Yes, of course.
So whether there are signed legal documents, no, it's too early. And reason is because first priority, it's done at QU, therefore first priority in legal terms, it's a QU.
Of course.
So therefore QU would have to decide, legal department of QU would have to decide how to proceed, what kind of agreement and so on. From my side, there are discussions and negotiation arrangements of potential application in clinic, both clinics, state clinics, and even private entities. So I would separate ideas and wish, let's say, how we want to do it, because we do it. I'm discussing, I'm talking with people with a legal procedure. This is two different things, one shouldn't mix it.
Yeah, it's very obvious. Yes, it's very clear. I hope it's clear for our guest who has asked this question. I have a question for you, Abdurrahman.
Right.
Well, the question says, for Qatari satellite company, which is a Sailsat,
Right.
is there any other objective than commercialization?
At the moment, I would say, unfortunately, I would say no, because we're still trying to build a sustainable business. So we're still in the progress of having a viable commercial company. So once we reach profitability, and then we can decide on, like investing and sponsoring more in different academia projects and researches and stuff.
Yeah, fair enough, of course. Yes, understood, fully understood.
But if I may add, I think with the companies like SK, there is another impact. It's the impact of being present.
True.
One can say that this technology demonstration. So someone can say, yes, Qatar has this technology demonstrated in country, which means there are people. It takes, 10 minutes to drive to landmark.
Yes. Yes, yes. And achieving having, I think you mentioned also, Abdurrahman, that we have two satellites fully operated.
Right. So
Number one?
right. So Sail 1
Yes.
was manufactured and launched in 2013 with a specific coverage. Like if I would literate that, like you will have to have a specific coverage for each satellite. So you cannot just assume that one satellite covering MENA region, which is Middle East and North Africa, will cover something in Europe. So it has its own spot in space. Now that's one, Sail 1, which is 25.5. Now Sail 2, which was launched in 2018, it has 26 degrees coverage, MENA 26 degrees. Now what we added on top of that is that you usually have different company to fully control and monitor those satellites.
Yeah.
Which can be done through like a different company in Europe or US or Asia, like East Asia. What we did in 2019 is that we launched our teleport, which is the most advanced in the region and the biggest in the region. Like we make sure that we go over like all the categories to make it the best and that can last for long. So what's special there is that we control and monitor both satellites. We have our own like 20,000 square meter of space dedicated for different kind of commercial, because what we do is not product necessarily, it's more services, managed services. So we would say like we can host antennas, we can host studios, disaster recoveries, and all kinds of stuff. So this is what the teleport is about, and how we are using it to control the two satellites in the air, in space.
It's very astonishing when we talk about space. So in here, in one platform, talking about space, but from like we have the science, the medicine, the curing aspect. I would focus about curing aspect of the cancer technology because that's the aim of it. You know, helping humans. And the disease is still there, anyways.
Right.
And
but
then
the thing is, I would like to add something, is that when you look at space, it's not just astronauts, NASA, and SpaceX. No, it's actually way more than that. If you look at them, they're more like the vehicles actually to go to space. Now, what do you want to take to space? That's up to you. In our case, we took our satellites and we're doing our own commercial operations of that. Now, in Dr. Sarhani's situation, he is trying to treat cancer. So in his case, he is shipping, basically, we were talking about this before the meeting, is that basically it's just shipping. So he is shipping
the seller.
his treatment
to
space, to leverage space in a different way.
Yes, indeed.
So space is a huge opportunity for everybody to leverage.
To explore, to leverage. And we are part of the space.
Yeah, of course.
We're part of the space. Well, I have another question here, that will it be able to treat occupations in space if your research will show positive results? That's to you, Dr. Sarhi, the question.
So short answer would be yes. And why yes? Because question already gave answer. And answer is if will be observed that there is inhibition of carcinogenesis. So it depends on results, and results we don't have yet.
Of course.
So if results will be of this kind, yes. Then you can ask me what is the chance that this result will be delivered, that it will be that result. And this is, I would say, probably, I wouldn't say 50-50. I'm a little bit more conservative. I would say maybe 10%. But this is not the purpose. Purpose is push cells to expose what controls them, what makes them to behave as a cancer cells. Because I mentioned in these networks, regulatory networks, we have thousands of components, and majority of these components are normal. They're not cancerous. They act in an abnormal way. And if we would try to use drugs against these normal components, we actually will harm people. We will not help them. At least help will not be efficient. Therefore, we have to find those few bad guys which makes everybody else around them behaving in abnormal way.
Yes, of course. We're really looking forward to see the results. Now, I have a question to you. That's my question. You've mentioned to me earlier, Doctor, and it was mentioned also in the presentation, that you have a schedule, a timeline, that was supposed to be in August 21 for the trip to the space.
Correct. If in next 3 days we'll be taking very important decisions, then yes.
So it's still August 2021, in the next August, basically, we are talking.
Yeah, we're talking about next August.
How will it take? How will it take on the space? For how long?
So timeline is for flight itself 4 weeks.
4 weeks.
4 weeks.
Okay. And there is no human going to there. It's the cell.
No, I'm too old. I cannot fly. Sorry. I would love, but no, it would not work. But on the other side, there is no reason of that.
There is no reason.
There is no reason because design of a module which will contain those samples is made in a way that everything what will be needed is when module is delivered to International Space Station, then astronauts will have to press a button on, and then when it's supposed to go back, press button again to switch it off, and that's it.
And that's it.
That's it.
That's great how technology what a human can do with technology, or what technology can do for a human.
It's both ways.
I would say it that way.
Okay. And what is after that? What's next?
Then next, in one word, collaborations. Because one part which what we will do is related, I mean, in essence, it's analysis of those cells, comparison. It's a lot of science. This is the reason why I was a little bit silent, because I was thinking how to formulate in one sentence all those complexity which will come back. So what will be next? Technically, it's taking samples to QU. Then taking them in work, what means taking them into analysis.
Yes.
And what we are planning, what I'm planning for myself, because we cannot do everything, is to planning by applying proteomics, systems biology, directed studies of signatures. However, the same samples can be used for many different other different investigations with different technologies for genomics, transcriptomics, animal studies, drug sensitivity. At least those what I listed.
Okay, great. Well, before we reach to an end, I would like to hear, Abdurrahman, how would you like to conclude? What is the message you wish to convey?
I would definitely reiterate on the importance of leveraging or having more initiatives to leverage the unique nature of space. It is extremely important for us to start now to end like maybe 10 years later, because it will take time.
Mm-hmm.
Now, given the challenging nature of developing drugs, not all experiments will see the light of success and will be commercially materialized as planned.
Mm-hmm.
However, it is extremely important for us to pioneer this segment, as it hasn't been explored, neither optimized.
Of course. This is a very important message. Thank you so much, Abdurrahman.
Thank you.
Dr. Serhi, lastly, as we are concluding, what is the message that you wish to conclude with?
People with visions and good ideas, get together.
Yes.
And right now we're talking about space.
Yes.
And I say it by purpose. I could talk about oncology, carcinogenesis, cancer, and so on, just go into what is close to my heart. And that would be close to my heart, but we are different people with different hearts, with different ideas. And if you want to explore whether this idea of space is of interest for you, go this night outside, look on moon, and see, is it something which excites you? If yes, think. Maybe you have something to add. You see, it can be even something so diverse, so different like art, not necessarily engineering or biomedicine. Because art at the end of the day is also part of our life. So it's about life, looking on life in different ways. Whether we will succeed or not, it's another story. Whether we will be professors or we will never be successful, it's another story. But at least as long as there is ambition, vision, idea, excitement about things.
Yes.
Also commitment.
And commitment.
Commitment.
And commitment is very important. Well, thank you so much, Dr. Serhi, for being with us today. And same also, Abdurrahman, thank you so much for being with us in today's webinar, which is the first webinar of the Qatar University Wednesday research series. It was about not a new technology, I wouldn't say new anymore after the webinar, the cancer in space, taking Qatari flag through Qatar University to the National Space Station. One last thing before we end our webinar, I would like to highlight that the link to today's webinar, the recording will be sent to you through emails. The link will be part of the Research Wednesday's website, in which all the information of all the activities will be uploaded over there. I encourage you to register and be connected to all the activities that's yet to come. The very next activity, part of the Research Wednesday series, will be from another platform. Today we were hosting from using technology, the webinar. The next episode will be from another platform, which is purely social media, through Instagram Live at Qatar University QU Research account. The topic will be led by QU Press about a topic that is important for each and every researcher, scientists, engineers, anybody in any technology, which is publication. Where to publish, why to publish, how to publish, and much more will be discussed on 2nd of December. Stay tuned and be with us. And thank you so much.
Thank you.
Thank you.